Okay, welcome back. This is the virtual residency workshop 2022. This is Friday, July 1st. It's our last day. And I want to introduce our opening speaker. This is Jason Wells of Harvard, who's going to be speaking on research data management. So Jason, take it away.
Thank you very much. I do want to make one thing apparent right at the beginning of this, which is that, yes, I work at Harvard. For 25 years before that, I worked at a very, very, very tiny school. And so I've had certain privileges since November when I joined Harvard, but most of this is aimed at kind of both perspectives. So I'm here to talk about research data management with you all today. That's not working, and I need a laser pointer. What we want to do is kind of go over the concept of research data management, introduce what exactly it is, talk about the need for research data management, the solution that has really been identified, the facets of a research project, and introduce some of the data life cycles that have been introduced in order to make research data management a little bit more accessible for everyone. I'm then going to be discussing one data life cycle in depth and how RDM is changing. In this part, we'll go through a bunch of different demos because I really want to get everyone up to date on why, how to go about doing this with your faculty and facilitate their grant requests. We'll then document how you can help and introduce some communities for further help if you need it. There's one thing that I need to stress right at the outset. When we're doing some of the demos that we'll be doing, you can log in through an ORCID ID. If you don't have one, it's probably worth going out and Googling ORCID ID right now. I realize it's a double thing there. The ID is built in there, but just go off and get one. You're going to need it to log into some of these different services that are out there. So the idea of research data management, this is a definition from the American Library Association. They're saying that it's a broad concept that includes processes undertaken to create organized, documented, accessible, and reusable quality research data. And we'll ask why. The changes that are taking place right now is that the NIH is actually putting through a new policy right now that says that your scientific data has to be preserved and shared through the submission of this data management and sharing plan. And more to the point, there's now a compliance section where they want to actually know how you're going to comply with these data management plans and what you're planning on doing with it. Why would they ask this? What is so important about sharing your scientific data? Why do they actually care about compliance? You know, there's a lot of questions that are brought up by this change. This is a really good video. I have not played a video in this, so I'm curious how this goes. Can everyone hear it?
No.
You can't hear it?
No.
Henry, any ideas here?
Honestly, I have no idea because I've never tried to play
So-
audio.
This is Josie. You can, when you do the share, just click on the share the audio and box.
Where? Oh,
Henry might have to give you a permission, but you're already sharing the screen, so you could just click the video checkbox.
You'll probably
Yeah,
need
so
to
try this.
reshare.
Jason, can you unshare your? Oh, is it
Yep.
making the sound now?
I'm working on it. I've lost my cursor as well, so this is
Okay, so what you could do
fun.
is stop
There we
share
go.
and then share again and see if there's a share audio option. I'm gonna go ahead and
Share
make
sound. You're
a,
absolutely right.
co-host.
No, there's a share sound button that I needed to check. I apologize.
Okay, great.
Good Lord. This was not needed before.
Is it asking extra questions?
Everyone's still there?
We're here. We see your screen.
Okay, let's test this again. Can you hear it now?
Now we can hear it.
In 2011, a team of physicists reported a startling discovery. Neutrinos traveled faster than the speed of light by 60 billionths of a second in their 730-kilometer trip from Geneva to a detector in Italy. Despite 6 months of double-checking, the bizarre discovery refused to yield. But rather than celebrating a physics revolution, the researchers published a cautious paper arguing for continued research in an effort to explain the observed anomaly. In time, the error was tracked to a single incorrectly connected fiber optic cable. This example reminds us that real science is more than static textbooks. Instead, researchers around the world are continuously publishing their latest discoveries, with each paper adding to the scientific conversation. Published studies can motivate future research, inspire new products, and inform government policy. So it's important that we have confidence in the published results. If their conclusions are wrong, we risk time, resources, and even our health in the pursuit of false leads. When findings are significant, they are frequently double-checked by other researchers, either by reanalyzing the data or by redoing the entire experiment. For example, it took repeated investigation of the CERN data before the timing error was tracked down. Unfortunately, there are currently neither the resources nor professional incentives to double-check the more than 1 million scientific papers published annually. Even when papers are challenged, the results are not reassuring. Recent studies that examined dozens of published pharmaceutical papers managed to replicate the results of less than 25% of them, and similar results have been found in other scientific disciplines. There are a variety of sources for irreproducible results. Errors could hide in the original design, execution, or analysis of the data. Unknown factors, such as patients' undisclosed condition in a medical study, can produce results that are not repeatable in new test subjects. And sometimes, the second research group can't reproduce the original results simply because they don't know exactly what the original group did. However, some problems might stem from systematic decisions in how we do science. Researchers, the institutions that employ them, and the scientific journals that publish findings are expected to produce big results frequently. Important papers can advance careers, generate media interest, and secure essential funding. So there's slim motivation for researchers to challenge their own exciting results. In addition, little incentive exists to publish results unsupportive of the expected hypothesis. That results in a deluge of agreement between what was expected and what was found. In rare occasions, this can even lead to deliberate fabrication, such as in 2013 when a researcher spiked rabbit blood with human blood to give false evidence that his HIV vaccine was working. The publish or perish mindset can also compromise academic journals' traditional peer review processes, which are safety checks where experts examine submitted papers for potential shortcomings. The current system, which might involve only 1 or 2 reviewers, can be woefully ineffective. That was demonstrated in a 1998 study where 8 weaknesses were deliberately inserted into papers, but only around 25% were caught upon review. Many scientists are working toward improving reproducibility in their fields. There's a push to make researchers' raw data, experimental procedures, and analytical techniques more openly available in order to ease replication efforts. The peer review process can also be strengthened to more efficiently weed out weak papers prior to publication. And we could temper the pressure to find big results by publishing more papers that fail to confirm the original hypothesis, an event that happens far more than current scientific literature suggests. Science always has and always will encounter some false starts as part of the collective acquisition of new knowledge. Finding ways to improve the reproducibility of our results can help us weed out those false starts more effectively, keeping us moving steadily toward exciting new discoveries.
Let's see. So how can I now advance the slide? All right, so that's an example of what the problem is. One of the solutions that's come up is this idea of open access to the data that the researchers are doing and this concept of FAIR. So this is a shorter video that's only about 2 minutes that kind of introduces some of that. from Maastricht University.
No matter what kind of research you do or where you are in your career, sooner or later you will come across the FAIR principles for research data. Applying the FAIR principles means to make your research data findable, accessible, interoperable, and reusable. Findable means that others can discover your data. Accessible means that your data can be made available to others. Interoperable means that your data can be integrated with other data or can be easily used by machines. Reusable means that your data can be used for new research. These 4 principles should be applied throughout the entire data lifecycle, and they are closely interconnected. Please note, applying the FAIR principles to your research workflows does not necessarily mean that you share your data openly. FAIR data is not the same as open data. Open data is data that can be freely used, shared, and built on by anyone, anywhere, and for any purpose, while the FAIR principles provide a set of best practices for sharing data, respecting any ethical, legal, or contractual restrictions. If your data contains personal information or is subject to copyrights or intellectual property rights, you must comply with regulations and protect your data from unauthorized access. But even if the data itself cannot be shared openly, you should create and publish a description of your data, so that researchers with a relevant purpose can request permission to reuse the data. This module introduces you to best practices for making your data fair. Following these best practices will help you to produce high-quality data that can result in maximizing your research output and impact and enhancing your recognition as a researcher.
All right, so hopefully that just wedged everyone's minds open a little bit. Let's go back to here. So the real question is, what can we do as facilitators to help our researchers and faculty accomplish the goals that we just outlined? And so a lot of this is actually what's happening before our researchers and faculty actually need a supercomputer. What can they do? What I wanted to do is just introduce a little bit about the grants process and some of the concerns that an average faculty member might have. And so with the types of funding sources, typically we're talking about private companies, foundations, or individuals. What I've seen at my school is there's large companies that will come in and ask a researcher to do some research, and that's called the industry-sponsored research. There's an A after that I've forgotten the name of, but agreement. So there's a variety of ways that this takes place. We also have the public sources that I think most people are more familiar with. NSF grants are pretty familiar. You'll hear Henry and a lot of other folks who probably talked about campus CC Star types of grants from the NSF, but our researchers are getting stuff from DoD, DOE, et cetera. Let me get my laser pointer back. So that plus the institutional considerations. I have been at an institution where faculty were signing their own data use agreements. I'm now at an institution where faculty have to submit the data use agreement to an actual website, and I'll show an example of that in a minute. But this runs the gamut. Your institution is likely to be extremely different than either of those models, and it might be similar to either of them. I don't know. That's one of the reasons later on I'll point out that you really need to talk to your grants folks and find out what's going on. But no matter what, some of your faculty are signing these data use agreements to get data from a third party. We also have private money that's being used to fund research, and so you'll sometimes have issues with outside activities and interest reporting, where a faculty member might, or gift terms, where a faculty member might need to dictate to the university about why they're getting the gift that they're getting and what they're going to do with it. And how it might intersect with whether or not they have stocks in that company or something of that nature. If people are being researched in any way, even with surveys, sometimes the institutional review board has to come into play. And so it always makes sense to pass things past the institutional review board. And then if there's any harm that can happen with data leaks or breaches, there's this newer concept called research data safety, where it's a group of people who just know a ton of stuff about preventing data leaks and breaches and other concerns of that nature, that you can submit your request to them and go through them for preventing those types of issues. And then staffing, if you're launching a large research project, you've got labs. I've got a lab that has 50 people in it, and that's a lot of turnover that happens every couple of years. And so staffing becomes a very big concern going forward. There's also practical considerations such as your lab meetings. What software are you going to be running to use those lab meetings? The chat, we've all done the pandemic 101, right? These communication things are standard to us, but what's happening with a lot of these grants now is they're looking for archiving and recording. And so this meeting is being recorded. And so Zoom is obviously one that we'd be talking about for Zoom, but then to document collaboration, it turns out that Google Docs or Microsoft 365, a lot of them are doing sort of versioning histories and things of that nature. Code collaboration, I think GitHub has really become the de facto standard in this part, but it's important to identify what your IT solutions are going to be and how you're going to standardize them. And then, like I said, with that lab that's got 50 people, if people are trying to do different programming styles or naming their files in different ways or anything else, really, it just becomes a bit of a rigmarole in order to share their projects. So standardizing in a lot of this makes sense. You saw in the FAIR video that they were talking about using life cycles to standardize the efforts. I want to just point out that the life cycle that you saw in that video is not the life cycle that you will see at Purdue, where the second bullet says acquire, discover, and reuse on this bullet. University of Reading, instead we're collecting and reusing only here. Here's the University of Tasmania, where we're collecting and capturing and preserving. And then Memorial University, they've kind of tossed that whole model out and are stating their own things here. University of Arizona has their own model that's, I think, most similar to the one that we saw in the video. And then ETH Zurich. This is actually my favorite one just because it doesn't look like all the other ones and actually gives us a little bit more detail about what we'll be doing at each of the stages that I'm going to go through with you all. But the one that I ended up having to use is the one that Harvard Medical School uses, which is this gargantuan one that introduces all of the different stages here, but then spells out exactly what's happening within those stages on the periphery of it. And then this idea of stuff that's happening at all times is in the middle here about data safety, data security, and storage options. So I've adapted that for what I'm doing at Harvard Seas, but the idea is I've kind of renamed a couple of them because we've got a different type of project close that we go through. And what I'm going to do is just step through all of these and give you demonstrations of a few different products that we're using on a day-to-day and go from there. So what is a data management and sharing plan? Let's see if I can escape. Nope. Go into this one. This is an example of a data management plan. This faculty member, Damien, or Dr. Romero Diaz probably, had to write this up in order to make this application for a grant request from the National Institute of Health. It has been shared publicly, thankfully, and that's the reason that we're able to look at it. But this is a project abstract that they've written, just detailing the research that they'll be doing and why they're doing it, learning about some of the different algorithms that they'll be doing and the goals that they're doing for it. And that's just the introductory one, but the data management plan itself. How can I zoom in? I think it was. I don't know if everyone could see that. Make it a little bit larger at least. Talking about the types of data that the professor or the researcher is going to be generating. And so they've created this nicely formatted table here where we can see the number of files that they'll be creating for data for these telephone calls that they're doing. And we think it's going to be about 1 gigabyte, and there'll be MP3 files. He's basically trying to give an idea of exactly everything that's happening for this research project. The description of what scientific data will be preserved and shared then takes a look at all of that data in that table and figures out, okay, here's what we're going to process, here's what we're going to try and put up on a website so that people can actually see this data and work off of it in their own research. The metadata then, where they'll talk about how they're going to lay out the metadata a little bit, is how people will go about finding those publicly shared files. And it's insanely important today. The related tools and software and code They're giving an overview of exactly what types of tools they're using in order to process these files. They're naming names as to versions within those programs, different types of libraries that they're using within Python. PyTorch and TensorFlow are very popular. They'll go through and tell you URLs in order to download those packages and applications. Standards, we're talking about what standards are you employed whenever you're doing this. And so the Microsoft Excel format, they're talking about WAV formats, MP3 formats, and the like. They're basically just trying to introduce everything that's being used within this research project and give an overview of it. They even kindly bring in data dictionaries, things of that nature. So this is an example of a data management plan. They're just giving an overview of every possible facet that you can come up with for what a data management plan looks like. I just checked the chat, Ryan. I will. There's actually a link within the slides, so if you can go get the slides. This is the 9H one on slide. Where am I? 22 should be on page 22, and this is the link that we're at right now. But that's an example of the 9H one. In the NSF, it's a slightly different plan. And this is, I don't want to go into the minutiae of it, but it's just got a slightly different format that they're asking for. And more importantly, you can see it's not as rigorous as the NIH one. NIH is really leading at this point. And then here's an example for a Department of Defense plan that's sort of like a sample one, because those don't get publicly done very often. But again, it's kind of similar. I thought it was funny that they've got a justification for restriction of data. So if there's legitimate reasons that you can't preserve and share data, you want to have to cite it there. They didn't answer that question on the sample one, but obviously for DoD research, there's a good reason for not sharing and not preserving data occasionally, or more likely than not. So that's an example of the DoD one. David, yes, that's exactly where we're headed. DMP tool is what I wanted to introduce everyone to. So that's on slide 24. The differences in all the different grant application agencies is the reason that DMP tool exists. There's an actual website where 330 institutions have participated in creating this website. It's free to use. If you have an institutional affiliation, you can log right in. If you don't have an institutional affiliation, I believe it still lets you in just nicely. I think I logged in earlier today, so this should just work. So whenever you create a plan, it'll say like what institution you're at, but then it wants to know what the funding agency is. And they auto-populate as they go, but they want to know, let me see, National Science Foundation. And then they'll ask what template I want to use. So I only got the Harvard ones, but I believe you'll just have like a blank template if you want to, but I'm going to mark this as mock, and let's call it, I know there's ORs in here, so I'm not sure if I still need to fill this one out or not, but let's do test one and create the plan. Of course it's not working. Maybe this is the problem. Okay, so now that I selected the thing correctly, that we're getting more things that are populating here. So we could choose like the chemistry division or the computer information science and engineering division. But go ahead and create that plan. This is DMP tool itself. Once you get into there, The Harvard form is specific to what the Harvard Medical School is built up, but you saw that the reason I was only getting that was because I hadn't written out the National Science Foundation one correctly. So now that we've got it correctly written out, we get the ones that are built for each of the different facets within NSF, Annalie. But you can give it a title, we can give it the abstract, we can do the research domain starts and ends. We've kind of already said that it's the National Science Foundation, but talk about the funding status. So this is a planned one that we're hoping to get, opportunity numbers and grant numbers, but I'm trying to get to the meat of it. This is a place where you can add your collaborators, and then this is where we actually write the plan. Let's open all of these. You saw these questions being asked in the sample plans that we were looking at. So it's up to the faculty member to go through and free text enter these in. And that's the problem. In a lot of ways, the faculty or institutions actually need to know what materials are out there for them to use. And that's the reason that we're going to introduce this life cycle in a minute. But entering the metadata standards, this is all the stuff that we just saw. Let me see. Just looking at the chat here. Yes, I do believe the California Digital Library created this as well. So it's difficult for a faculty member to go through and figure this out. They actually need training to be able to answer these questions. But that's DMP tool. There's another one about research outputs, so they can talk about how the fact that there will at least be a paper that they're doing, but also that there'll be a GitHub repository of their code and the like, and then a way to download the plan and setting the font of it and everything else so that it can actually be out there. So that's that. No problem, Dirk. I hope you really like it. Back to here, and I'm going to tell a horror story sooner or later, but you guys will like it. But in the planning and designing section, that data management plan is only one part of what the faculty member has to actually put through. They've also got to be thinking about a project abstract, the research question, budget, research plans, materials for institutional review boards and data safety and everybody else, as well as how the research will be conducted. You've got this lab of 50 people. How are we actually going to go through and manage what people are doing and the like? Metadata is extremely important these days. It's the Web 2.0 world, and it's a question of how people are going to find your research project. How are they going to find your paper, et cetera? And so putting in plenty of metadata information in everything that you're doing, the PowerPoint slides, the research papers, making sure you're filling everything out so that it's got a ton of information in there for people to search and find. This is one thing that people need to think about, is a metadata tags that they want to enter in, and where they're going to put these in, and why they're putting them in. All right. So then part of also what you need during the planning and designing phase is these onboarding and offboarding checklists. I also have these in Adobe here. I mentioned that staff of 50 individuals. So what are we doing with those 50 individuals? You just hired somebody. We have to review the lab policies with that person. We're saying that we need to create a preliminary data workflow with that person, the new person that we've hired, developing organizational workflows, creating workflows, creating README files for all the data sets that they'll be working on and are creating. And you'll see this in some of the offboarding documentation, but they want a knowledge transfer file for when this person leaves. And so it makes sense to actually start writing that transfer file when you get hired and you're talking about the stuff that you're doing, just to give people an idea of what's happening. Storage options. So at HMS and at Harvard Seas and all the other schools, a lot of what's happening for the storage options is actually happening in research computing. That's part of the reasons that you're all here listening to this presentation. But they want to know what software options are out there. How can I do software and backups, storage options and the like. Reviewing the policies around data security, confidentiality, intellectual property. We have to think about everything for everyone who's joining the lab. Electronic lab notebooks are really big in Harvard Medical School because they actually have to store all the decisions that are made whenever they're doing a research project. And that all gets documented in these electronic lab notebooks. NIH has a requirement to do that. So these are all out there. An offboarding checklist that you can see this one's it's half the size of the onboarding one because there's less to actually worry about. We want to worry about that transfer file. Making a little bit more fleshed out now about what's supposed to go into that knowledge transfer file, but then talking about the data retention of the data that they've got. I've got 2 faculty that are leaving in a minute, that are leaving. Oh, they left well, yesterday actually. So we're revolving questions right now about, one of them has 60 terabytes stored on the research computing servers, and we need to figure out what we're going to do with that 60 terabytes. Did they take it on their own to their new institution? What's happening with those? So that happened. Talking about reorganizing the data, transferring permissions and the like to new colleagues. Talking about what needs to go on long-term storage. So there's 2 different types of longer-term storage. There's sort of stuff that's available to your other lab mates on demand, and then we can put stuff onto tape as well. That's a little bit more difficult to get your hands on. I think it takes about a day to get the tape stuff, but just trying to lay out exactly what needs to go where. So those are examples of that. I gave you little links to onboarding and offboarding that Harvard has, HMS has. So those are the important links that you can see there. I have to check and see what this chat is. Dina, that's an extremely good point. Darn, I wish I put that into the presentation. I'm sorry. Accessibility standards are extremely important as well, and making sure that people can sort for that way. I will update the presentation for next time to have that in there. So the other thing that we've got are these internal controls. Data use agreements. I wanted to give everyone a chance to see what this is. The Healthcare Cost and Utilization Project. This is a sample data use agreement that has to be signed in order to get access to the data that HCUP has. And it's going through and naming some things where we want to talk about how you can't identify people. This is de-identified data, and so they don't want us to sit there and try and re-identify people. And so there's a bunch of promises that have to be signed saying I won't release or disclose this data, that I won't attempt to link to it or link to other records from this data. Protection of establishments. I'm not going to try and publish what I'm doing with the data itself. It's only what I've learned from the data that I can publish. Limitations on data use, sharing, and disclosure. Please don't leave the CDs on a bus and then forget about it. That sort of thing. But it's essentially working out what internally, but spelling it out that you're now on the hook. If you violate these agreements, they can and will sue us if needed. One of the horror stories I'll tell is there's a document like this. This is clearly legalese. It's clearly something that needs to be going through a general counsel. At smaller schools, there isn't, let's say, a system set up. And so the faculty don't know that it should be going through a general counsel. And as a result, they sign these things on their own and they assume the legal responsibility as such. Whereas at a larger school, at Harvard, for instance, I actually have to submit this to an organized system in order to get this thing signed. So as an example, this is the Harvard research portal. It's talking about there's places in here for signing data use agreements, data safety, organizations I can never remember, abbreviations I can never remember, and then OAIR, which is the outside interests and activities reports. So this is an example of where we go to submit a data use agreement where I can upload that agreement if we need to and send it off to the lawyers essentially to go have a look at it. Outside interests and activities, outside activities and interest reporting. It's a similar idea where they want to just ask you, what are your disclosures? I'm getting a grant from Microsoft, and it's because I know so-and-so, and I happen to own 1 million shares or whatever. They really need to send this off to the lawyers and ask if there's a conflict of interest here. And so that's what this is talking about, and why it should be studied. At my smaller institution, this was completely unknown. No one was looking at this. It wasn't anything. Whereas at a larger institution, they are thinking about it. Let's see. Institutional review boards. I'm sorry, I should have included a small video about this, but an institutional review board is a group of people at your university who are out there to take a look at different research projects that are happening and making sure that you're not basically abusing people. That's a really horribly brief introduction to what an IRB is, but the idea is that you'll submit your study, the different parts of what you're doing. This is only page 1 of what they're asking, but they want to make sure that you're not going to breach some of the protocols that have happened in the past, where there's some there was a psychology experiment at Stanford, I think, that scarred children for life, essentially. There's a lot of different examples like that, where projects really needed to go through somebody for a clearer head to sit back and kind of say, like, maybe we shouldn't be doing this. Maybe we should do this a different way. And that's really what the IRBs exist for, is to help you think through things and understand why you shouldn't be doing things the way that you might be thinking about it. Yes, in some ways they're a pain in the butt. I have a survey that I want to do for a paper, and I could do a survey for staff reasons, no problem. But because it's something that's going to go into a paper, it has to go through the IRB. But again, they're there to prevent us from horribly harming people. And so the IRBs are really important. Your faculty member is going to hopefully know about them, and we'll be going through them as well. Data safety, like I said, is sort of a new one. Yeah, that's the prison experiment. That was a big one. Data safety is another thing that's newer. Like I said, I have some faculty right now that are doing research with industry. I can't name the companies, but the intellectual property that they're getting access to has some serious concerns about the fact that you can't store it on just any laptop. It's got to be an encrypted laptop with a detachable hard drive that's also encrypted. We want to make sure that that hard drive is locked in a safe all the time. Those sorts of things, and that the computer is never on the network or something of that nature. There's a lot of different types of standards and responsibilities that come along with the research that the researchers are doing these days, and we need to make sure that there's an organization that can help them comply with those types of prescriptions that are happening. So this is the first page on what we've got at Harvard for getting that process going, and this will kick off an email to a data safety officer, school safety officer, I think it's called. And they'll contact the researcher and actually start helping them get the data to whoever they need to get it, and make sure that they're doing it in a safe and correct manner. Check the chat real quick. I would assume that data security is part of data safety. It seems like, at least at Harvard, data safety is the overarching thing, but I'll get to that in a second as well. Okay, so like I said, lab of 55 people or 50 people, we want to make sure that we've got some conventions going on with naming of files. Did Jason Wells do this, or did Henry Neiman do it? What's the reason that I'm doing it? Is it a presentation that I'm doing? And so that's the name of the presentation that I'm literally doing right now. And I shamefully have not actually named the directory this, but ideally people are using some sort of a directory structure that's naming the institution, the school, the person that the PI that is leading this research, and what the research is about, and the instance of it, and possibly even tossing a date into that so that we can find it with different search mechanisms that are out there. Earlier I talked about version control with handling it with different programs, Google Drive, GitHub, etc. Programming conventions, this is something I know people don't think about, but again, when you've got 50 people all working on the same code, it can get a little beefy. And so standardizing some things like cap for variables, but then doing a lower and then a cap for functions. I've even seen some people that do conventions within variables. Have your arrays stated one way, but then have your simple integer variables stored a different way, strings a different way. That way, I'm just on the fly. It makes things really easy to identify what's where and how it's working and why. And then it's the concept of README files. We want to understand why you've written this code. Why is it important? What version is it? What changes have been made since the last version that you wrote? That sort of thing. Is this role part of the CISO office or in a different admin unit? Thanks. Melissa, it's at a large institution, it's complicated. At a small institution, everything was happening in the CISO office. The larger institution, we've got people at each of the schools that serve as a security officer, and they have sort of a dotted line back to the CISO office, but their primary is to the school itself. So it's kind of a bit of both. Analyzing and collaborating. Like I said, with the NIH, they've got some requirements within different types of grants that that you're tracking just about every decision that's made and why. You saw that in the video about spiking the rabbit blood with human blood. That's the sort of thing that would have to be documented. Why did you go off and do that? Okay, that's a good comment. So, you know, that they want to document exactly what's happening and why. Different programs exist to do that. I'm going to show the open science framework. See if I can log out. I need to know that. When you come to this website, sign in, I want to point out, I had you all create ORCID IDs at the beginning of this. It is really worth it because you can get access to, you know, the institution ones. Not everyone has their institution set up on this, but if you have an ORCID ID, you can get it. And so it really opens up a lot of different doors that you can't normally get access to. Yeah, so unfortunately, I do actually have access. I'm going to go that way. Whoa, I don't, excuse me. Really, in the middle of a presentation? This is what I get for testing things, and it works perfectly. Okay. And now it works. Okay. So with the open science framework, sorry, I'm moving things around here, but we can give it a new title like test and say create. Good news, it actually worked. When we're creating these, again, we've got the metadata decisions. What tags you're going to assign to this so that you can get things created correctly. The nice thing about the open science framework is it gives you a lot of different options for where to store data. And so we can actually put it on Dropbox or Google Drive and the like. Let's see. As you get the ID and access, you need to use a fully encrypted computer. That was just an example for so Martin asked, as you get the ID and access, you need to use a fully encrypted computer. For ORCID, no, there's nothing to do with fully encrypted computers. That was just an example from something that's happening at Harvard right now with a person who's getting access to really specialized data. ORCID is just a regular ID that you can get that doesn't rely on the encryption. I think it's probably encrypted at some stage, but what I wanted to show here though was if we, oops, files, does that. I wanted the wiki. I can edit the wiki to say hi, go back and save. Then let's edit it again, change hi to hello, save it again. It's creating this chain essentially so that, again, if anyone challenges your research, you can actually see who edited it, the time that it happened at, and then go back and see the original version that was written. And so we can actually understand exactly who made what change and why. But again, it's necessary for people to be documenting. So if that researcher who spiked the rabbit blood with human blood didn't document it, we wouldn't be able to catch that problem. But this is one step towards solving that sort of an issue where we're trying to document everything that we're doing and why. And it's this documentation expectation that is, the way my mom used to put it, is keeping honest people honest. You know, we want to make sure that people understand that they're going to have to document everything they do. So don't do anything that you wouldn't want to document, essentially. But then there's little bits of analytics that can come into play in OSF. Registrations, contributors, different types of things here. So we'd have about 55 to 50 different people in this lab that might be talking about the contributors. Well, that's a good point too, Annalie. Tracking versioning is also helpful as project members join midstream, so they can understand exactly what's happening and why when they're coming in, 3/4 of the way or whatever else. It's really useful. Okay, so that's the open science framework. With Analyze and Collaborate, it's funny because a lot of this was written before the pandemic, and so people are talking about collaborative tools and software. You know them now. We all learned them during the pandemic. So it's Zoom and Google Docs or whatever else. It's perfect for our needs, but in reality, like some of the NIH grants, they really want us to be recording the meetings. So pay attention to what's in the grant applications and what they actually want you to be doing, because you may need to pivot a little bit. Analysis ready data sets, what they're saying with these is it's sort of a way to prepare a data set for public release. You might have variable names like HUCs is clearly, for me, Harvard University School of Engineering and Applied Sciences, but no one else is going to understand those acronyms. And so stripping those things out and just saying this is the presentation makes it a little bit easier for the public to understand what's going on. And you want to strip those things out, kind of normalize the data as much as you can, just prepare it and make it easy for the public to understand what's happening before you release a data set from a research project that you're doing. Image management is another thing. I didn't think I had to worry about this until we had people starting to talk about training artificial intelligences, and suddenly they were bringing in thousands upon thousands of images. And there's two different programs that will help you work with that sort of thing, where if you need to find a specific image within that, it just gets a little bit difficult with the file system searches that you've got, where they only search the file name. They don't really search the metadata. Tropy is one example. I think I had it open. That's this guy. Think of this, literally what it is a, you can see all the files from the file system perspective, but then there's an SQL database sitting on top of it. And so if we want to make a change to all of these different files, and literally there's several thousand files here, it's quite easy to just say visual question answering to stand. Why must it happen? I can then go down this way and just immediately make that change on all of these files. So it's that SQL database ability that's making it work really easily. I think I added a note to one of these files way down. And so it bears in a cage is the actual image that we've got in this data set. And it found it really easily, despite not being in the name of the file at all. It makes working with images much more quick. And like I said, when I saw image management, I thought, oh gosh, I don't know how people are going to, I don't think people at our school are going to have to worry about this, because we don't have, for instance, NIH researchers who are looking at millions of microscope images or the like. But it turns out with artificial intelligence and machine learning folks, it does become quite important to do. Let's do that. So also under Evaluate and Archive, this idea of archives and record management, I talked about it a little bit, but when you talk to your research computing folks, they're going to give you different options. Archiving, it's sitting on tape. It's really cheap. I think it's $5 per tape at Harvard. But then having the more accessible types of data sitting around so that people can access it really easily costs a bit more. And then we want to actually make those arrangements at this stage and refer to the at all times slide, which you'll see in a minute. But you know, it just makes sense to go through and think about your options. This is part of my job. I've got a slide on what I'm doing, but I'm trying to encourage people to use the double dollar sign rather than the triple dollar sign and the single dollar sign to save a little bit of money for the department because we're centrally funded. We also need to worry about intellectual property. So if you've created something that you're planning on spinning off, there should be a general counsel or an internal office that would help you figure out the types of concerns that you've got. At Harvard, there's an Office of Technology Development that you fill out this form, and then a person, usually a lawyer, will call you back and talk to you about the project that you're doing and exactly whether or not you want to do it as part of Harvard or if you plan on spinning it off from Harvard and you know, how you want to spin it off, that sort of thing. So these folks are ready and willing to help faculty work through these problems. We're getting into more of the data retention type of stuff here. So data retention itself, you really need to study what is in the grant application that people are doing. If it's an NIH one, for instance, they want us to hold the data for 3 years after the final financial report. But if there's an allegation of misconduct somewhere during those 3 years or before, we actually have to hold it for 6 years after the final resolution date. This makes it difficult whenever you're doing a grant application because you don't know if there's going to be an allegation of misconduct. So they're budgeting in their grant applications for X dollars per year and not really knowing if they need to cover 3 years or 6 years. So those are issues that have to be kind of figured out and guessed about. I think in this case, the university would probably pick up the 6 years, the additional 6 years, but you know, it's just a gotcha that can happen. NSF, it's only 3 years. They don't worry too much about it. But then we're also talking about data destruction. If you guys are geeks like me, I'm guessing you've kind of geeked out on this topic. Tomes have been written about data destruction and how many times do we actually have to delete a file and overwrite it and then write weird data on top of it and verify that it's done. And you know, I just wanted to say that there's a huge difference between what an average hacker can do, what folks with magnetic force microscopy can do, and then what sort of like the NSA can do. In this case, you can see the standards that are out there. I've got the URL that I grabbed this table from up here, but you know, talking about if you're going to do DoD standards, we want to make sure that you overwrite your data 3 times and then make sure that the pattern used is all zeros and then all ones and then a random character after that, and verify after each time that you write that data that it is what it says it is. You know, these are just examples, and you can see some people are talking about doing that 7 times. I remember back in the 80s, the standard was 30 times. It changes over time, and so it's important to go through and have a look at what you need to do and why. Under the share and disseminate part of the life cycle, we were talking about scholarly products, and it's really dependent on what I knew I was going to get a comment. I haven't been able to find the policy. Melissa, let me think about that. I Googled NSF retention policy and it's different for different parts of it. I didn't link to it. I apologize. I'll have to think about that. I definitely Googled for it. But you know, the types of different stuff that we produce during projects, the data itself of what you're doing in the project, the metadata, the preprints that are happening, code that you're writing, believe it or not, protocols. If you're in a wet lab talking about, you know, we mixed region A with the region B, and then we got region C, and then we added hydrofluoric acid to that, and just the protocols that you're using can actually be documented on protocols.io. I talked about those regions, and you can share those too, believe it or not, as well as things like training materials. Sharing regions, believe it or not, the XIM bio is a place to actually upload your regions. You can tell these folks how you actually made your regions and start commercializing them. So there's a variety of different things that you might not think about as a scholarly product that actually can be a scholarly product. Giving other organizations access to your region is a huge thing so that they can do follow-on work with what you're doing. Also, with sharing and disseminating, we want to be thinking about the data repositories that are out there. I tried to include some links here to some of the big ones. I didn't know this when I was at a smaller school. I want to promise I'm not trying to just talk about this because it's Harvard. But like the NIH ones, it's a little bit difficult to find the exact one that you want in a specific domain. Dryad, if you don't have an ORCID ID, it's very difficult to get them to give you an account. But then on top of that, they might be not willing to give you more data if you need it. Dataverse, it's free for everyone globally. I would start with Dataverse before I look at anything else. I don't know why they did this, but Harvard is all I can say. But there are tons of other data repositories out there. So look around, try and look for the ones that apply in your field. Dataverse demo. Let me check that. Dina says we have a multidisciplinary data repository for folks on our campus and people who are working with folks on our campus called the Illinois Data Bank. And that's a great example. Elizabeth is asking, does the Harvard database allow data storage on AWS S3 buckets or Google Drive? I don't know, actually. I'm not specialized on it, but we're going to go look at it and maybe we can figure that out. University, continue. Understand why this is all of a sudden a problem. Anyway, so this is an example of data that's been uploaded to the Harvard Dataverse. I've seen people all over the world uploading to this. If we wanted to upload our own data, I don't think it actually takes it to the level of us seeing whether or not it's going to an S3 bucket. I think here. API tokens, add data. Everything is obscured by the Zoom windows. I apologize, but if you wanted to do a new data set, doing the title, the author descriptions, related publications, doing about the notes and everything else, we would just upload it into the system. I don't think it gives us the understanding of whether or not let's see. Hey, Remitter's on, cool. Working on a version to support external stores and allow access to data using Globus. Thank you, Remitter. Remitter works with me at Harvard. So it is Globus that's backing this. But we can upload all of these different things. And you'll see though that we've got a little bit of issues here. A maximum of 1,000 files per upload. The maximum file is 2.5 gigabytes. And then we've got sometimes things that need to be known about tabular file ingestions with 143.1 megabytes for some of those. And so you really need to pay attention to the different prescriptions of what you can upload when and understand that. I am going much slower than I thought I was going to be going, so I'm starting to worry about running out of time. So I'm going to keep going. Preprints, archive and beyond, and then publishing your actual file itself, publishing your journal article. There's a ton of different preprint servers that are out there, and we're having a lovely time with trying to understand all the different ones that are out there and what faculty can use. But it's this idea that you've probably heard about it. You Google a file or a journal article, and it's sitting behind some paywall that you can't get access to it. Well, it turns out that there's a lot of different preprint servers out there where you can upload the journal article before you actually publish it in a journal, and that's why these exist. I used Archive for mine, so I wanted to give a quick demo of this. Preprint archive, log in. Obviously a LastPass user here. But so this paper actually went up prior to us publishing it, my collaborator and I. I think the conference was literally on Monday. So it was important for us to get it into the system as quickly as possible. It's really nice. The submission process really is not difficult at all. We have to certify that we are who we say we are. That's actually incorrect there, so I have to change that. Sorry. Go ahead and choosing the Creative Commons license that you want to apply to it. I think most people would probably do the perpetual non-exclusive license, but you can choose to do Creative Commons ones, and then choosing a archive and a subject class for the paper that you're uploading. Then I won't actually step through this because we're running short on time, but adding files is the next process. So just the PDF that you've produced of your journal article, it processes that, and then it's going to ask you about all the different tags that you've got and want to apply to it. And then finally, we do a preview of it and hit submit. So I'm going to back out of this just so we don't create any problems. Okay. Also, at the project close and extended missions, I think this is called reuse at on other data life cycles, but reproducibility, we want to make sure that everything that we've done is actually able to take a researcher who's not connected with your group and actually reproduce the work that you're doing. Also going through that offboarding checklist with folks that are leaving and creating a knowledge transfer file. Let's see, so for an example, for a knowledge transfer file, like I said, I moved on from my old institution in November. This is the types of stuff I had to put into that file. They wanted to know the current status of all the projects that I had worked on ever, but only the ones that still existed. So that's why the word extant is up here. And then talking about importing contacts that people might need to know about it at different institutions or that I was working with or the like, usernames and passwords, the code, documenting each of the projects, why I did them, and where they were being taken, the way that they were going. And then, of course, they wanted to know how to get in contact with me after I had left and understanding that. At all times, this has a different name on different life cycles. This really belongs in an at all times bucket. We always want to be thinking about data security, the idea of encryption, access management, patching, etc. We should all be always doing this stuff. Also talking about data safety, the idea of the security levels. People don't think about sanctions and ITAR and standards and the like. It's common for people in the medical field to be thinking about HIPAA, but there's some data sets and the like where you can only have people who are from the United States who can work with that data set. Sanctions levels, there's literally, I think, upwards of 600 people just on US sanctions list right now. It's probably increased several thousand in the past couple of months. But it's important to go through and understand and make sure that people that are working on your project are able to work on it. And that's part of what your data security office might be, the CISO, some of those folks can actually help you understand exactly what types of things you need to worry about for this. So this is the University of California's data safety levels. You'll find this at a lot of the larger institutions where they're putting things into levels and then saying this system is only able to be used with this level and below. So for instance, here at the University of California, they're saying public websites and publicly available data for protection level 1. This is nothing. You could have this be stolen and be quite happy with it because it still counts as marketing at this point. Whereas level 2 data, Cal gives us a really good idea. Data security doesn't resonate well with our researchers, especially those not already used to HIPAA. Data integrity is a term that seems to work better. Thank you, Cal. I will, that's a really good idea. We might carry that back to Harvard. The higher levels of safety levels here, though, are talking about risks that can happen to individuals. For instance, that's probably a bad example I shouldn't talk about, but they're talking about what happens if we violate a statute or a regulation that through a data leak. So the idea that it's a low level of risk for this one, but then I wish I could move the windows. Statutory information. This is probably where they're storing their HIPAA and FERPA stuff. But your different storage options, for instance, are tied to what you can store where. These are examples of the storage costs at Harvard FASRC. I can tell you that for the most part, on our levels, we can only handle level 2 and below on all of these different options. If you want to do a higher level of data security, such as HIPAA, you need to actually contact the FASRC folks and understand what the options are and how they're going to have to build a bespoke environment for you and the like. So it gets a little dicey and a little complicated. Here, though, you can see as part of my job with research data management, I've got a lot of folks who are sitting on tier 1, and I was hired to encourage them politely to move to tier 2 or tier 3. That's happening to different degrees, of course. But you can see here that there's different options with this, and the Harvard FA, the Faculty of Sciences Research Computing, has laid things out beautifully with understanding, are there daily snapshots? Is there a disaster recovery capability built into this? Drop that down. Is it encrypted at rest? And you'll see that in a lot of the different standards that you have to meet, whether or not it's encrypted at rest, and you'll even see it encrypted in transit is another big one that is out there. So get a hold of what this looks like with your own research computing folks, or start talking to your IT division about understanding this, because the vast majority of your folks can probably rely on tier 0 or tier 1. Tier 2 with the encrypted at rest and the like, it gets a little bit more difficult. And then tape is beautifully cheap and a good place to put data if you can. After 2023, I wanted to say that we started this presentation out by talking about the changes that NIH is doing. It really looks like the NSF and DoD and a lot of the other agencies that are out there are going to be making these changes. They want people to consider FAIR. They want them to be out there publishing the data that they're doing. And they really want people sharing the research that they're doing. There's also some challenges. We've got people doing public computing on this data, and they don't have access to research computing infrastructure. At least within the biomedical community, there's this Use Galaxy that you can use. I don't know of any other examples, but it's a good one where it's just set up so that it spawns, I think, Google or Amazon servers to handle all the processing that has to happen in the background. They're not looking for you to use huge data sets with this, but as far as what classes are doing, it works fantastic. And that's going to become a more common problem. People are going to have to figure out how to actually process huge data sets going forward, and a laptop isn't really suited for doing that. Another good one that I wanted to talk about is sharing large amounts of data. I had someone come to me and say, I've got thousands of terabyte sized files that I need to process and store and share. There's a FAIR requirement for the project that I'm doing. How do I share these files? And I kind of put a question out to one of the lists that we've got, asking how they're doing that. And a lot of people chimed in, thankfully, and said, ask Dryad. Dryad actually was kind enough to help out a lot of folks with storing large amounts of data. And then the one that we actually end up doing quite often is Globus guest collections with a pointer in Dataverse. And so you can create a guest collection and make sure that it's set to public. This is an example from Globus's stuff. So that's just one way to do it. And if you face that problem, there you go. There's 2 ideas on how to handle that. But as far as what we can do, I think it makes sense for folks to talk with your data safety folks, talk with your grants officers, talk to sponsored research, talk to whoever you can talk to at university, and find out about how you're handling data use agreements. What does the IRB look like? What does options look like for intellectual property and data safety websites and applications? What are the storage options and security options that you have at universities? I gave you a good look at at DMP Tool. We talked about Trophy, we talked about Dataverse, I showed you a little bit about Archive. So you've got experience with these now and can actually go through and help people use those if you need to. I think that at a bare minimum, as facilitators, this is what we actually have to be able to show people. So we've got it quite a bit out there. But this is a good list of what we should be looking at. The communities that exist, I'm trying to hurry through this, sorry. There's specific RDM websites that are out there, and the not so specific ones. I can promise these guys are free. These bottom 2 bullets. These ones I believe are mostly free. There might be a token cost to them, like $40. I think one of them cost was the highest that I saw. Or you might need American Library Association membership for some of these, but it's worth hitting all of these websites if you get faced with this RDM problem and seeing what they're about and how you can sign up with them. If you're involved with research or computing at all, though, you should probably definitely sign up with these 2 at least. All right, and then a typical RDM job on a day-to-day basis. I wanted to just kind of show people what I do. I'm learning about research data management, producing presentations like this one, helping faculty doing data management plans, educating faculty about RDM resources, facilitating the lifecycle resource requests, tracking storage usage, and trying, as I said, facilitating cheaper usage, serving on university committees about research data management, also meeting with the administration over our research data management concerns, because it turns out the administration is extremely concerned about it. Did I misspell it trophy someplace? Sorry. Thanks, David. Tropy is Tropy. I apologize if I misspelled it someplace. It is not Trophy. And then discussing RDM with anyone who will listen. So hello to everybody. There is my email address. Please do feel free to reach out if you have any questions. What time is it? And how do I stop sharing? Okay, we have 5 minutes for questions if anyone has any.
Is this slide deck going to be available?
They're already up on the website.
Awesome.
Henry, I've lost the URL for the website.
I will put it in the chat.
I might have it.
And I will try to remember to also put it in the final mailing for the poke for the last session.
Okay, perfect. Thank you.
Jason, I have a question. Is there a go-to like community for research data management professionals? Like some list or community meeting or web meeting that happens?
I really wish I had a better answer for you. I've seen on the community slide, let's bring that up real quick. I like these two, I was part of, oops. The bottom bullets I was part of already because of research computing. I have seen these at different conferences and the like, the Research Data Access and Preservations Association, Force 11, but fundamentally I haven't found a go-to one. It's been funny seeing research data management pop up in the bottom too. It's gaining greater traction. When I asked the data librarians, hey, I'm giving this talk, what can I point people to? They saw the list and then had me add the top 2 bullets. So I'm guessing the top 2 bullets are the go-to ones for them, but I think they cost money.
Okay, that's fair. Thank you.
Sorry. How many of you are actually dealing with this on your campuses? Is it just a handful of us, or is it more common? So we've got a couple thumbs ups. UCSD is saying yes. So it's definitely something that if you're not dealing with it, you will be dealing with it soon. Hopkins is saying they have a lot. Okay. Well, Henry, I think we've tied up and exhausted our time.
All right, let me shut off the recording.